Project MZ2 is one of a number of attempts in physics in the past few decades to study the physical universe and its entities within a single and general framework. What makes, though, MZ2 different and probably distinct is its mathematical formalism and its context-based study of entities, which is complementary to that of content-based framework employed by almost all fundamental theories of physics, namely classical mechanics, relativity, quantum field theories, and so on. Regarding mathematical formalism, the central theme in MZ2 is the Riemann Zeta function, or its zeros to be exact, occasionally referred to as Zeta Zeros. These zeros employed by MZ2 to study and describe any entity, large or small, living or inanimate, in either of three realms of quantum, classical, and relativity, in terms of their distinct physical specifications or features, such as their eigenvalues. However, noting that there is an infinite number of Zeta Zeros, a question arises as to how an infinite set of zeros could be employed to describe a finite universe and or entities with finite number of specifications. This question has been addressed in MZ2, and the solution is offered by introducing a novel algorithm which would allow employing finite number of these sets, the number being determined by the application in hand as long as it is not too small. Actually, this is the backbone of this algorithm, is the backbone of this project. All this has resulted in establishing relationship between the Zeta Zeros with not only the prime numbers but also the eigenvalues of random Gaussian matrices. But more importantly, with the Planck Constant. Actually, Planck Constant has been calculated using the distribution of the Zeta Zeros almost exactly. That is around 99.9% of its known value in physics. This has led in turn to introducing a Hermitian Hamiltonian whose eigenvalues are given by Zeta Zeros, a requirement of Hilbert-Polya conjecture in the early 20th century, which was later refined and is now referred to as Berry-Keating conjecture. Now, having the Planck constant being calculated and produced by this formalism, a reasonable expectation from such formalism that claims that it studies the universe and its entities within a single framework would be that it produces the other physical constants of our universe too, such as speed of light, gravitational constant, Boltzmann constant, and so on. This matter is also handled in MZ2, but this time by studying the likely symmetries pertaining to Zeta Zeros via the simple groups in group theory. This research is young and is still ongoing, but so far, employing only the sporadic simple groups, it has been shown that the equilibrium state of maximum entropy has a symmetric group that corresponds to what is known as the monster group, which is actually the largest amongst the 26 sporadic simple groups. This finding led my student Mohammed Fatahi and I to calculate both the Boltzmann constant and the Higgs boson mass almost exactly, again around 99.9% of the known values in physics, using the specifications of this monster group. So by now we have 3 of nature's physical constants produced by MZ2's mathematical formalism. In the next step, the idea is to involve the remaining 18 infinite families of simple groups in our work, establishing relationship between them and zeta zeros and further exploring the physical constants. It is worth mentioning that all these findings and details of these discussions are compiled under 2 manuscripts which were sent around 2 or 3 months ago to 2 peer-reviewed journals, and they are both in the review stage and we are waiting for the outcome. Once the decision is made, the corresponding videos on these details shall be posted to our website or YouTube, and those interested might refer to them at the time. Okay, I think first of all let me mention this, that the title of Project MZ2, the title stands for Monster and Zeta Zeros, to portray their importance in the development of this project and their importance in our physical universe. Okay, I think this much on mathematical formalism would suffice for an introductory video. It is the right time to turn our attention to the physical framework employed in MZ2, which, as I said, it is a context-based study that complements the content-based framework, which is not only used in physics but also in many branches of science. It is occasionally referred to as reductionism, and it originates from Newton's idea of clockwork universe. Actually, based on the works conducted by mainly Galileo, Tycho Brahe, and Kepler, Newton, around 1680s, convinced himself that the physical universe could be thought of as a big clock. So he considered the universe as a big machine. This is important. It is known as Newton's mechanical view. It plays a major role in the development of almost all branches of science in general and in physics in particular, because it is on the basis of this view that Newton suggests to study such a big machine, and this is study to be conducted by one insignificant component of such machine, i.e. human being, as far as the size is concerned. The only viable approach would be to study the parts of this machine, then parts of those parts, and continue this until to the state that either technological limitations would stop us going any further, or beyond that, studying the components wouldn't provide any further useful information for our purposes. This is known as reductionism or content-based framework. It makes the backbone of all fundamental theories of physics and a major role, as I said, in other branches of science, but especially in biology and the related topics such as medicine, okay, which we shall discuss always. Our today's understanding of the physical universe, of the matter and its parts, of human body, of nature, all these technologies that today we enjoy, all are here just because of reductionism, because of this framework. That shows how powerful this and useful this framework is. But it has its own limitations too. And actually, it is these limitations that initiated the MZ2 project in the first instance around 20 years ago. In the following video, I shall discuss these capabilities of this reductionism and its shortcomings. And we shall see how the context-based framework of MZ2 can help to resolve certain issues regarding these shortcomings.